Hi, this is Andrea Hendricks. Let's take a look at some of the homework problems from section 6.1. I've just copied the whole assignment from my math lab and I'm going to work through these problems. There's not that many. If you go through some problems in the book and you have questions, don't hesitate to contact me about those. So the first problem is to write the standard equation for the circle whose center is at 8, 1, and whose radius is 4. So recall that the standard form is x minus h squared plus y minus k squared is equal to r squared. So we have x minus 8 squared plus y minus 1 squared is equal to 4 squared, or 16. And so that looks like part D. Find the equation on the circle having the center 0, 0 and radius 2. So likewise, we would do x minus 0 squared plus y minus 0 squared is equal to 2 squared, which is simply x squared plus y squared equals 4. Find the equation for the circle with center negative 4, 3 and passing through negative 3, negative 1. So this one is different. We know the values of h and k, but we do not know r. So to find r, we have to find the distance between negative 4, 3 and negative 3, negative 1. So we can plug into the formula x sub 1 minus x sub 2 would be negative 4 minus negative 3 squared plus 3 minus a negative 1 squared. So therefore we get d is equal to the square root of negative 4 minus negative 3 would be negative 1 squared is 1. And then 3 minus a negative 1 is really 3 plus 1, or what? 16, right? Because when we square it, we get 4 squared, or 16. So the distance between those 2 points is the square root of 17. So now we know what the radius is. The radius is the square root of 17. So to put it in the standard form, we would have x minus a negative 4, which would become x plus 4 squared, plus y minus k, which is y minus 3 squared, is equal to the radius squared. So when we square the square root of 17, we just simply get 17. So that one is C. Now, find an equation for a circle with center negative 9, 2, tangent to the y-axis. So at negative 9, 2, we are somewhere over here. Tangent to the y-axis would mean that it's got to touch the y-axis at that point. So in other words, the edge of the circle would be there. So that would take us over what? Yeah, 9 units. So we'd have to go 9 units in all directions. So this would be the circle we're looking at. But the key thing about that is we know the center and we know now the radius because of how it's related to the y-axis. So the center is negative 9, 2. The radius is 9. So our equation would be x minus a negative 9, or x plus 9 squared, plus y minus 2 squared is equal to 9 squared, which is 81. And that would be part C. It says use a graphing calculator to graph the circle defined by the equation x minus 2 squared plus y minus 6 squared is equal to 25. What are the two functions that would have to be used? Then select the correct graph. Well, we know, first of all, the center is 2, 6, and the radius is 5. So we're looking for center of 2, 6, which looks to be A. Now, how would I enter that on the calculator? I'd have to solve it for y. So we would first have to remove the term with x. So we would have y minus 6 squared is equal to 25 minus the quantity x minus 2 squared. Now we would need to remove the square by applying the square root. So this would be y minus 6 is equal to, the square root property, which would be plus or minus the square root of 25 minus x minus 2 squared. Now we can bring the 6 over to get y is equal to 6 plus or minus the square root of 25 minus x minus 2 squared. So we have 6 plus that and 6 minus that. Okay. And that looks to be part B. Now graph the circle, find its domain and range. X squared plus y squared equals 9. We know that the center is 0, 0. And the radius is the square root of 9, or 3. So we're looking for one at 0, 0 with a radius of 3. Now it looks like our graph is counting by 2's, right? So this one looks to have a radius of 3. What is the domain? Well, as we move from the left to the right, remember if we're graphing this by hand, we would go to 0, 0, and we'd go out 3 units in all 4 directions. And so this would be at what? 3, 0, negative 3, 0, 0, 3, and 0, negative 3. So our domain are values from left to right for the x, so that would be from negative 3 to 3. And our range is from bottom up, which would be from negative 3 to 3. Graph the circle, find its domain and range. X plus 5 squared plus y minus 3 squared equals 4. So we know that the center is negative 5, 3, and the radius is the square root of 4, which would be 2. So if we're looking for a center in the second quadrant, right, left, and up, with a radius of 2, on your problem sets, you have the little magnifying glass that allows you to expand it. It's very difficult for me to understand what's been going on here with these graphs. I think, let's see, negative 5, it's 2, 4, 5, 3, and up 2. I can't tell clearly if that's up 2 or not. It may be D, C or D. I can't tell without a magnifying glass which one of those it is, but just count your units very carefully whenever you're choosing those. Select the correct graph, and then what is the domain? So we'll just think about this. If we're at negative 5, 3, and we have to move 2 units in all directions, 2 units to the right would take us to negative 3, 3. 2 units to the left would take us to negative 7, 3. 2 units down would take us to negative 5, 1. And 2 units up would take us to negative 5, 5. So the domain has to do with the left and right values, which would be from negative 7 to negative 3. And the range has to do with the y values, which would be from 1 to 5. Okay. Find the center and radius of the circle. So this is where we have to complete the square. We would have x squared minus 10x. To take half of 10 as 5 squared, we get 25 we have to add. And to complete it on y squared plus 8y, we take half of 8, which is 4 squared is 16. And then don't forget to add both of those numbers on the other side. So we really have x minus 5 squared plus y plus 4 squared is equal to, when we add all of these up, what do we get? Say negative 32 plus, is that 41, would be 9. So the center is 5, negative 4, and the radius is the square root of 9, which is 3. Number 9, very similar to that. We have to divide first through by 2, because you get to have a 1 on the coefficient of x squared and y squared. So we'd have x squared. We can go ahead and group the y terms over if you want, or x terms over rather, minus 10x. And then plus y squared. 2 into 2y squared is y squared. 2 into negative 16y is minus 8y. And then we'd also have to say 2 into negative 80 would be negative 40, but we need to carry that to the other side to make that positive 40. I know I did a lot in that one thing. So divide everything through by 2, group your x terms together, your y terms together, and get the constant on the other side. To complete the square half of 10, 5 squared is 25. So we add it to both sides. Half of 8 is what? 4 squared is 16, so we add it to both sides. So we have x minus 5 squared plus y minus 4 squared is equal to the sum of all of these. What is that, 81? Okay. So our center is 5, 4, and the radius is the square root of 81, or 9. Now we have x is equal to y squared plus 1. So remember, this form is x is equal to a times y minus k squared plus h. And so what are our values of h and k in this particular problem? Yeah, it would be 1, 0. Oops, sorry about that. Get it right? Okay. Yeah, so we'd have a vertex at 1, 0. See, the roles of h and k are kind of reversed whenever we're reversing the roles of x and y from a vertical parabola to a horizontal parabola. And so we know the vertex is 1, 0. What is the axis of symmetry? Well, the axis of symmetry goes through y is equal to 0, which is the x-axis. And the domain is what? Well, we're choosing the graph here. 1, 0, it opens to the right because we have a positive coefficient, so this would be the graph. So their domain would be from 1 to infinity. And what about the range? Well, that goes from bottom up, which would be from negative infinity to infinity. And now we need to worry about completing the square here. We would need to take out a negative 1 to make that y squared minus, what, 4y plus 4. But in doing that, notice that y squared minus 4y plus 4 is already a perfect square trinomial. Right? If you take half of 4, you get 2. Squared is 4, and it's a positive 4, which is what we have here. So this is really the same thing as y minus 2 squared. So that tells us that the vertex of this horizontal parabola is 0, 2. And we know that the value of a is less than 0, which means it's going to open to the left. So we're looking for one that has a vertex of 0, 2, opens to the left. And the domain is from negative infinity to 0, including 0. And the range would be negative infinity to infinity. And that is all for these problems. That was working through every single homework problem. So if you have any questions, don't hesitate to contact me. And let me move that back down here in case you need to look at that. Sorry about that. Thanks. Bye-bye.